Okay, so let's hop on and jump start the development and deployment of your Clojure web applications. So my name is Lucas, and I will today explain about and give you a bit of an insights on Hop and about its capabilities. But first, I want to give some background a bit about who is behind Hop and how it came to be. So starts at Magnet. As I was saying previously, I joined Magnet 5 years ago. This year will be almost 6 years. It's a small company based on north of Spain. And for all this time that I have been there, we have done a lot of stuff, a lot of interesting stuff from logistics system for lean manufacturing to predictive maintenance IT solution, renewable energy planning to IoT platform for solar panel data visualization, and a lot of other stuff. And we have always used the same base tech stack, always based on Clojure. And we have been improving it and refining it over the years. Although in the last couple of years, it started to get a bit in our way in certain aspects. And there are some motivations that led us to create Hop. So you see, in Magnet, we use AWS heavily to deploy our final artifacts. We use it as our cloud provider, and all the applications that we develop, we put them there. And one thing that we struggled a lot throughout the years is that when we have a new project and we have to set up a new project and deploy to that infrastructure, we need to do many manual operations to set up that infrastructure. We need to go to the AWS and follow documentation that we have and go through all those steps and set up the infrastructure. And these steps are manual mechanical work. And even though it's documented and is like a streamlined path that you have to follow, it has a great margin to make mistakes. And that's one of the things that we don't want to lose time with, because for us is like already a trivial thing, and we just want to set up the infrastructure as fast as possible and move on and get to the project, the main problem, right? The other thing that we didn't we started to not like a lot is that we inconsistent reusing of existing pieces of code. What I mean by this is that in many projects, what we usually do is, okay, maybe we have some this implementation that we can reuse in another project. And since we do projects mostly in parallel, many projects in parallel, sometimes these pieces get lost in different projects and get updated, but is not propagated later on to new projects or existing projects. And we would like to move these things if they fit into a library or a module, and make sure that we keep them in a single place and update it consistently. And these things, at the end of the day, they contribute to making it hard to keep consistency across different projects, right? When you start a new project, you want that project to have all those pieces that we usually use on our tech stack to be up to date and be consistent with our way of doing things. And of course, we also saw that there was a problem that there are too many ropes to learn for newcomers. So when you have new members or new developers, giving them the task to start new projects or even to start developing new projects was kind of very hard and a very tough task, because there's a lot to take in, a lot of knowledge that we built throughout the years. And that's one thing that we with Hop, we're trying to minimize or shorten the path for that. And the last thing is that we also want to improve what we already have. At the end of the day, we always strive to make things better, right? It's always a good thing to improve what you have. And so with these things, we thought, okay, we have all these different pieces, and some of them are mostly manual operations that we have to do, and manual things that we need to mechanical work that need to do. And in these cases, we did what we usually do best, right? As programmers, we automated it in some way. So the idea was to take all these pieces and put into something that can help us create something that can take on all those tasks that we were doing until now, and also improve it in some way. So that's why we came up with Hop, which is this platform that we have now that binds together the development purposes things with also the operations. And that's what we have developed to not only help us, but also we also open source it so other people can also benefit from its capabilities. So hop, right? So what is it, hop exactly? So simply put, hop is an opinionated rapid application development platform to create Clojure-based projects, mostly geared towards web applications. And one of the main important things that hop wants to do is to boost your project startup, right? By automating all those stuff that you would probably don't want to lose time with, such as your development environment, your CI/CD machinery, and deployment infrastructure. And for now, from the get-go, we have AWS and on-premises deployment ready. That means that you can already start by deploying things on AWS and also doing on-premises projects if you want. And we have a series of profiles that you can choose from that we'll go into a bit more later on this presentation. But basically, there are components that you can pick that enhances your new project in certain ways. So to provide all of this, we decided that we needed a tool so that can both automate this and provide other utilities. And we came up with the hop command line interface tool, which is just a CLI tool written in Babashka. And the main objective of this CLI tool, apart from other things, is to bootstrap new projects. And to bootstrap new projects, you need some set of configuration, need to configure things, right? And in the CLI, it provides two sets of configurations, or I would say, apart from other things, that you have to configure mainly, which are first the profiles that I said. The profiles are basic components and that you pick as additional functionality to your project. It might be persistence, for example, the hop persistent can give you a database locally and also set up the database in AWS, an RDS service for a database, or you may want authentication and you can choose between, for example, Keycloak or Cognito. There are both identity providers and they will provide both the services for you and also the some templating for your project for doing authentication on the front end and having set up the backend validation for the tokens. And you also want to configure the deployment target where you want to deploy things. In this case, cloud provider on premises are the offers for hop. At the moment, cloud provider is only AWS. And to configure all this, we provide a built-in web-based configuration tool that will go into more detail in a bit when we do the demo. But basically, this configuration tool is a front end that gives you a selection of the profiles. You can here pick what the functionality you want to have in your project, and you then configure the details about it. And I will go more into this for sure in a minute. And apart from that, the CLI is not the only useful for you while you are doing the setting up the project. Is also usable afterwards, because we provide at the moment some utility tools that you can use to do daily work. These utility tools are based on AWS and Keycloak. They have some tools that you can use. For example, you might want to download the environment variables from the production system in AWS, or you might want to connect to the production database, or even get details about the user that is in Keycloak. So these things are things that we usually want to have them or terminal and easily accessible instead of going to the cloud provider or to the infrastructure, specific infrastructure, to go there and click here and click there to get the information. And so with that, just as an overview, what the CLI basically does. So once you have the configuration, once you have set up the configuration that fits your needs, the first thing the CLI will do when it grabs that configuration is to set up the infrastructure. In this case, AWS, it uses underneath behind the scenes CloudFormation. and uses the CloudFormation API and deploy or create all the services required by your configuration in AWS. And after it's done with that infrastructure setup, it also generates all your local environment and project files. That means creating the CI/CD files, rendering the application files, and also deployment files that are useful for deploying the artifacts later on. So I will do now a quick break for a demo, and then I will continue with the presentation later. So I will switch back from the presentation to my terminal. Hopefully you can see it. And in this terminal, what I'm going to do is I will open up the settings editor and I will show you some details about it. So first, this is the CLI, so hop bootstrap, which is a subcommand, and open settings editor. Whoops. Okay, so this will open, this will run like a small backend in Babashka. We're actually doing this with HTTP kit. So basically we are running a small backend inside our Babashka CLI. And here, I would just maybe move this a little bit here because it's taking space. And this is the settings editor. So this is one of the first things you will do is basically configuring what you want your project to have. And after you select these profiles, which are basically the things that you want to add to your project, you then can configure the details about it. So you have seen this in the presentation. This is derived from the settings event, which is actually exported by this front end. But first, what I'm going to do is that for this demo, I'm going to use a file that I already created beforehand, especially crafted for this presentation. Unfortunately, I won't be able to show you the AWS setup because it takes a little bit, and so I will pick an on-premise setup, which is rather quickly, and we can see how it works. So basically, here I have some profiles selected. The core profile, which is mandatory, which has the bare bones of the project. The front end, so we can see a bit. We can see the web application running. And then on-premises profile, CI/CD, and authentication key code, which also depends on the persistent SQL because it needs a database for it. So in this case, these are all the details that I have configured here. And once you are done configuring, because you can use this to either set up a new project that it configure something from scratch, or you can use it to configure a node file that you have. And then you can just hit export, and it will just export you settings.even file. And I will get to that settings.even file in a bit. So that said, this small front end, one curiosity about this front end is that maybe you might think that this is done like with serving just static files in index.html with some JavaScript, but in fact, what we are doing actually is that we are using Cytle, which is an interpreter for Clojure script that allows us to actually run Clojure scripts on with Babashka. And basically what we're doing here, we have some dependencies for Cytle and also some plugins that we have here for reagent reframe because we construct the front end with these two libraries. And and with this, we can keep running with Clojure, of course. And we basically serve this with a small backend, and this gets served as static files, and then the scripts are executed just as they would normally, as in JavaScript, for example. And that's great. And so, talking about the settings file that I told you previously, the settings file looks like something like this. This was actually the initial version of the Hop CLI. If you have played with this tool before, back in the day, this usually you have to edit it manually, like entering this file and change it to fit your needs, which is quite impractical at this point because it's very, very long file. So and I will explain why it's a very long file. So basically, to design this, because the front end, what is actually doing is grabbing this file and constructing the whole UI. We inspired this on the Max customization subsystem. My colleague Bingen wrote a nice blog post about it. And basically, this is like a tree-like structure where each of nested maps, where each map is a different setting. So each setting is self-contained, so they have all the properties that is required to show this on the UI, to construct the UI, and also to use it programmatically when we are doing the machinery to set up the new project and use what you provided to actually do useful things. And of course, when you import some of these files that I imported here previously, we actually validating it as well. We do this using Mali. This is also in Babashka. I can show you really quickly. Settings reader as just a curiosity thing. And basically, we have a registry, which has a recursive schema. So it's basically, we have every setting, which we can have groups of settings, but they always loop into itself, right? It's always using the same base properties plus the possibility that they can have these properties where that you can group settings. And the other thing that is curious about this is that we also inspired a bit on Integrant, because we can also have these kind of things which are called references, because the settings, they can also depend, or profiles can have settings that can also depend on each other. Because maybe they don't have that value because this value is generated by another setting later on at runtime. So what we decided to do was to take inspiration a bit from Integrant and implement some, if you might know, Integrant is basically similar to Integrant keys, where we reference another setting in the configuration file, and it gets resolved later on in the runtime. Of course, it's just a very small subset like of what Integrant does. We don't do all the dependency graph generation and all the resolution based on the dependency graph order. It has like a explicit order that has to follow, but it's more or less what we wanted to do regarding this to resolve this dependency thing. So that said, I will go back to the terminal. And what I want to show you here is how we can bootstrap the new project. So here we have the settings that I created beforehand. So what I'm going to do is bootstrap the new project. And by the way, these commands, they all have their options and subcommands and documentation. So you can always write the subcommand and commands that you want, and you will print out the options that you have. And if you want to see everything, you can go to our documentation, the docs.github.dev, and there we have the whole reference for all the commands, subcommands, and their options. So in this case, I want to set up a new project. The settings file is this file here, London Clojurians demo.settings again. And then I want to create the project Clojurian, London Clojurians demo. And so it will set up the project in that directory. So there is one thing here to notice is that after you create a project, at the moment, we are printing out some additional steps that you have to do after you generate the project. That means, for example, these steps are meant for if you are setting up later test environment or production environment, and these are some of the things that you need to do in order, for example, to run the database. You need to connect to the database and run some SQL to create some schemas and users, and it has sensitive information. So at the moment you have to save it somewhere safe and then later on reference it to actually use it. But we are also thinking about some strategy which is still in design phase to actually save the settings or the computed settings after it is run for the first time, and that you can save it in your Git repository, and that's safe in a safe way that is encrypted, and you have a master key. That's the only thing you need to know to then encrypt that settings file and use it to do other operations. But for now, that's it. And so that said, I will go to the new project directory, and here, sorry, my microphone disconnected. Can you hear me? You can hear me clear now, right? Okay. So these are the files that we that the hop CLI generates. And here to start the project, we basically want to do just start dev. That's all you need to do to start all the services that you have. In this case, we have Keycloak service, we have Postgres, and the application, and also Nginx, that is the reverse proxy. So when you hit this, oops, sorry, always systemctl start docker. Oh, yeah, demo effect. Yeah, I always have this thing shut down for some reason. Okay, so when you hit start dev, it will spin up the environment, it will run all the services, and the application will not actually start a web server, but it will just spin up the REPL so you can connect to it and then start running the web server. So let's wait for a bit while it starts. And okay, so while it starts, okay, so there we have the REPL. So we can now actually connect it. So I will open it with Emacs, and I will open here, connect to the remote REPL. And here to actually run the project, maybe I will push this here because it's my site. In this case, we have to do a couple of things that are a bit more tied to the framework that we use behind the scenes that I'll get into it a bit later. That's Duct. And basically for Duct, you have to load the configuration by going to the dev namespace or loading the dev namespace. And then you need to run that configuration by using Go. So this will actually run the configuration that your system has. And in this case, also spinning up the web server for us. So this shouldn't take nothing because we have very little things there. So in this case, it's already running the server on port 3000, but we are not going to access it through the port 3000 because we are running on a proxy, on a reverse proxy, so we can just access it through localhost. So if I go there, this is the homepage. What that comes with a front-end template. So just showing that it's running. And before I finish this, I want to show you a couple of things. So here we chose the Keycloak service as part of our new project. So I can access it through this path. And what I want to show you is some how we usually do use the utility tools, for example, the Keycloak utility tools for this case. So what I want to do is I want to log into Keycloak just to show you that we have a user there. And we are going to play with the details of that user. So here we already have the London Clojurians demo realm. And here we have a test user with some basic credentials. So I'll switch back to my terminal. And here I want to, go back here. And what I want to do is, I already have these commands prepared. So Keycloak, yeah. So for example, I want to get the user details. So these commands are really available. So sometimes you want to check on some user and you can give the details to the CLI. As I said, you can always get the commands and see which options it provides or check the documentation. And this will bring me the details of that new user, which is test user that we have that comes with a template of the Keycloak service. And in this case, we also want to get, for example, the ID token for this user, which is a thing that needs probably a bit of background, and I will explain to you right now why we need this. So this will get a token, and obviously this is an ID token, is a GWT token. And we have this command here, and not only because it's fine to have it here or it's useful, but it's because in Hop, the protocols that we use to authenticate users is OpenID Connect. And we often need to test things and, for example, get a token for a specific user and call the backend with that token, right? And for that, and since everything hop is based on this specific way of authenticating, then this command is very useful because you can get easily the user token and then use it for something else. So basically, the structure that it generates, there is two parts in this. And please, my colleagues that are probably in the chat, if you think I missed something, please, you can speak up. So basically, there are two parts here. The first part is that when you enter the directory that the project that HopCLI generated, what you will see are basically the environment files and other files related to CI/CD and also Docker and other files for the service as well. But they are basically files meant for the environment. That is not related to the application code, let's say. And here you find many files for Docker Compose because they are separated by service, and these are basically the configuration for each service. I'm not sure if you want to walk through that or you want to go more to specifics like application code, but because maybe walking through all these files are a bit too much. But basically here is the environment files. The important files here you want to use in your development is the start and the stop. The start dev is basically a shell script which will spin up the environment and make sure that any state, for example, you usually have when you are developing Clojure, you usually have the target folder, right? Since we map the target folder to your host machine, you might have compiled classes from previous developments. And what we do here is also clean that up and start from fresh state. So it's basically spin ups your project from the Docker Compose files that you have there. And oops, I almost want to be in Emacs. And you have files, configuration files for development for proxy, which basically sets up the reverse proxy stuff for the services, for the applications, for the supporting services like Keycloak. And there is a thing about this that is a bit opinionated, is that in the case of these reverse proxying locally, the additional services are mapped. For example, Keycloak is mapped to a certain path like localhost/auth that I showed previously. And this is separated as well by services. So here you have the specific configuration for application and the specific configuration for the Keycloak part. And the same goes for the services. For Postgres, you have initialization scripts that are divided into between deploy and to develop. Things that are only executed, are only meant for development is here, like initial state, as I was talking about. This is for creating initial state in the database, like creating users, the schemas, and setting up the database for development. And for example, in case of on-premises, you also have here the on-premises files that you can use later on to set up the on-premises deployment. Keycloak, which is also very specific configuration to Keycloak, is basically initial state for development. So you can have that realm that I was showing in the demo, that you have some user and you have a nice startup to start developing with Keycloak. And here we also have, for example, in this case, this configuration was using GitHub Actions as the CI/CD provider. So you also have here, for example, the GitHub workflow for CI/CD. And this is basically the file that will run all your CI/CD scripts. And if I show you the CI folder, which is here, which contains the scripts that is used to run the environment, or sorry, the environment, the CI/CD pipeline. And basically here you will find all the scripts that is used, and they do very basic things. For example, linting test will just execute the commands to format, to pass the linting the tests, the linting, and other things like building the application image, which is going to build the application image and then publish it to your chosen Docker registry. And then you have on-premises. For example, in this case of on-premises, there are some other specific things like scripts for creating the bundle. We don't have anything on the deploy because that's up to you, how you deploy that on your infrastructure. We cannot assume how you do that, but there is a file that you can actually use to create the bundle, like the thing that you are going to deploy, which is this. And okay, so apart from CI/CD, there's some other supporting files like the environment files, where you have the environment, develop environment, and environment files. And you also have this is the Docker file that is both it has multi-stage build, because we want to use this Docker file in the development, in the CI/CD, and also to build the final artifact. So it's multi-stage. So you have development, you have the base one with the packages, for the one for development, and then CI/CD, and at the end you have the production one, which actually runs your artifact, which is a jar at the end of the day, an Uber jar, better said. Uh, so this is the environment, and from the application files, when the app folder is where the actual Clojure application is. And here is just a basic laning and setup. You have your project.clj as usual. You have well, gitignore and things like that, but you have also the dev folder, which you have code specific for development, and this is primarily things for Duct, and also you can have other things. For example, we used to have mocks in these folders as well, but they are basically things to start the development environment. And of course, there are some utilities as well that we added that comes with the base template. For example, test utils that are things to start doing test more quickly, or so you don't have to do some other things that Duct does. And let me see. Okay, so and then we have the resources and the SRC and test. Okay, so the resources, you see the layout is that it has resources, the name of the project, and then you have these three things. First, the index HTML. If you selected front end, this will be here. And then you have the config then, which is the basically what Duct uses to run the system. So you have the config then with all the integrant keys that launches different things. For example, this is for the API. It runs the API with rated. This is some integrant key for the API for giving configuration about keyclub, because the front end will need it, and these kind of things. So here is all the integrant keys that the project uses. Apart from the modules, there's some other configuration. And in the public, you just have things about CSS images that you are going to use on the front end. Okay, so moving from resources, in the CRC, you have the project folder with the source files, and this is thing specific to Duct. This is a Duct hierarchy file. I'm not going to go into that, but at the beginning it's empty because in this case we are not doing anything fancy with it. And then in the other folder, this folder, London Clojurians demo folder, you have the actual application or the code of the project. And initially we have this layout with the configuration I used. In this case, you have the API, which contains API related things. So you have a main file, which is basically the rated configuration. This is for setting up the router and also all the other routes, because the routes are separated independent. They are independently. They are by namespace. So, for example, the config namespace has its own definition of the routes. And then you have some things. Or oops, I pressed something in Emacs. Okay, this thing is okay. Okay, okay, yes. And then you have some other things. If you selected, for example, authentication, in this case, we selected Keycloak. It gives you other things such as, for example, middleware for authentication. This is basically for validating validating ID tokens and OpenID Connect tokens. And you have other things such. This is basically a macro that we usually use for responses, to make responses more readable. For example, if you want, not real, but more convenient to use, for example, an OK, and it will just return a 200 and then with a body that you want. And this is for the API, and the boundary is what I was talking about, the ports and adapters architecture. This is basically what your communication with external systems implementation should be. So in the ports is basically the definition. It is commented. This is for the persistence SQL profile. It generates this, but it's basically the definition. You define protocol that you want to use. In this case, we have some protocol here. It could be user, for example. And then you have the adapter, which is the implementation for that. In this case, the implementation is a SQL. And at this point, we don't have anything. We just have an integrant key that initializes a record that receives the spec, the DB spec, I might say. And this connector thing is basically the record for the SQL. And then you can have here the implementations. What we usually do, for example, is create a SQL folder and put all the SQL implementation for the things that we want to do in there. And this will pretty much be the places where you want to define and implement the external communications. And then in the client folder, you have all the front end. If you selected the front end profile, all the front end code. This is a boilerplate that sets up a little bit of architecture for the front end, like setting up the routes and some localization as well with Tempura, and basically mostly setting up a bit of architecture so you can start with something. And then we have, well, this is the entry point. The client is the entry point for the front end. Oops. And you have the main, which this is the entry point for the duct that this is run on the production system. That's what's actually gets run when we run the jar in the production Docker file. And finally, of course, depending on what you configure, you will get more things here or less. And then we have shared, which is basically some utility things like functions and, for example, localization, where we have the dictionaries and so on. And of course, the static root, which is to render the initial entry point of the application, which is that index HTML that we saw before. And okay, so that's it I wanted to show you. In this case, I would just go back to the, oh, I'm already in the directory and to stop the project so it doesn't do weird things. And I will go back to the presentation. Okay, so let me go back here. All right. So apart from this that I show you, Hop, it mainly is for setting up your new projects, but it also has a lot of things baked in when you create the new projects, the projects files or the different environments. That's also things that is a part of Hop, and is the way it pushes you to do things, right? And first, I will start by talking about a bit the local environment, what it is there, what you should expect in there, or what's a bit behind the scenes. And so the local environment that we created previously when we bootstrapped the new project, it is based on Docker and Docker Compose, right? The whole environment is set up using these technologies. And it's basically because we find that Docker can give us this self-contained and reproducible environment, because we want that every environment, not only development or CI/CD or production environment, are as similar as possible, and also because we want them to be exactly the same between different developer machines, because we don't want to go and run into the issue of it works on my machine, right? And also because you want to be reproducible, we also want it to be ephemeral and have no state at all. This can convey different meaning, but what I mean by no state is that you will have an initial state that you can set. For example, as we saw before, in Keycloak, we already have some pre-configuration, some initial state, for example, for development that is the London Clojurians realm, right? That's an initial state that's always there because that's something that we configured. But the subsequent states that are generated because you have the system running, you can reset it to the initial state at any time by just shutting down the environment and running it again. So you always start fresh So we always have this reproducibility in every machine and at any moment any moment. Okay, so the application template or the project template. Here, depending on what you configure, you can get more or less things, but there are certain things that are very basic for the for Hop, and they are essential that always will be there, and is essentially what the core profile brings. And the first thing is that the project has the build tool as Leiningen. So Leiningen is the build tool of the project. So you should expect a project.clj there. And Leiningen, we basically use it in every thing that's related for in development and both in CI, because we use both for setting up the REPL, building the Uber jar in the CI, and passing and doing executing the tests and formatting the project. So we use it in many places. Duct framework, which is a very important piece of the application template. It's the framework that we have used and that we have put it in Hop. And if you may know, Duct is dependency injection framework, and we use it like for many years now, and also beta test in production many times. And we like it a lot because it also fits and encourages hexagonal architecture, porters and port and adapters architecture pattern, and is a pattern that we like the way we feel like it's a good way of developing software, because if you may know, this architecture pattern is basically making external communication with external systems to be at the boundary of your system, so that it's not connected or how is it? Yeah, it's not directly connected to your business logic. So for example, you might store files and images in AWS S3, but at some point you want to change to, for example, Google Cloud Storage, right? And you can basically swap implementations, but your core business logic doesn't know about that. It just knows that you store these things somewhere, but it doesn't know how and exactly where. So, and Duct fits this very well because it doesn't if we have to make this change, we don't have to go to the code and basically change this somewhere. That we basically change in a single place, which is the configuration of the system, which is a concept of Duct, and we just swap to a different adapter, and you are suddenly using a different implementation. But the code really don't know about that. It's just calling an interface that has some implementation for it. And apart from that, the application template, as I said, depending on what you choose, it can come with different things or different templating boilerplate. But you can also have different Duct components or libraries, I must say, that can fit for your needs, like authentication, PubSub, and that can even come with the profiles, as I said, because, for example, in the Keycloak profile, there are some Duct components that the Hop CLI adds by default, such as, for example, an authentication case, we introduce a library for validating the ID tokens. So Hop CI/CD. The CI/CD part, Hop does not automate the infrastructure setup. What I mean by this is, it doesn't go to your CI/CD provider or your repository or remote repository and doesn't create the repository and set up the settings for running the pipeline. What it does is it provides you the files and the machinery to run the pipeline on your provider of choice. So the idea here is that you build and ship on every commit to the deployment branch, and basically they are just plain old shell scripts with a bit of magic here and there, of course, but they are essentially that, and they just do pretty much generic things. For example, the CI scripts, they're easily portable because they are very generic. They just do basic things, such as running the tests, checking the format, and checking and passing the linter. And these things are also done inside Docker. That is, we run the pipeline on Docker as well. So we guarantee that what you are doing locally is also the same when you run in the pipeline. And the CD scripts are a bit more platform specific because it has some instructions depending on your platform of deployment of choice. And of course, we have the other files that are now CI/CD provider specific, which orchestrate these scripts to run your pipeline. Currently in Hop, there are two options: Bitbucket pipelines or GitHub Action, sorry. And if you do not want to use one of those, you can also do it yourself, in the sense that there is a custom option in the settings that you can choose. And what the Hop CLI will do is basically provide you the CI scripts, which are generic, and you can easily port them to your new provider. And last but not least, deployment platforms. As I said, there are two options: AWS or on-premises. In the AWS case, as everything else, it's very opinionated. It's an infrastructure that we have used for years and that we have tailored for Hop, and it works really well. We have run many projects and productions on that infrastructure. And for the case of on-premises, we cannot assume do a lot of assumptions about the infrastructure. The only things that we assume at base is that it's a Linux machine and it has internet connectivity, because since it's going to run on Docker, you probably will need to download some images or even your own images that uses an external Docker registry. And in AWS, we use Elastic Beanstalk as the service where we deploy your artifact. And in on-premises, as I said, you keep using the Docker and Docker Compose. We use, in this case, systemd for managed lifecycle. It's not like, because it's a bit to cover what Elastic Beanstalk does, not everything, because Elastic Beanstalk does many things that in this case, in on-premises doesn't do. But it's basically a way of managing lifecycle of the services to keep them running and doing health checks and these kinds of features. And then also some SSL termination support. That there are two options you can choose. Right now, one that you can, we provide some support to do it yourself, or otherwise you can have ones automatically that issue you Let's Encrypt certificates. And from the AWS part, other essential services that we use is AWS Elastic Container Registry for the app image storage. So when you build your Docker image in the pipeline, it will be stored in the ECR. And System Manager Parameter Store for the environment variables. If you have used Elastic Beanstalk before, you might know that you can also put the variables there. But we suffered over the years that Elastic Beanstalk has a limitation and for environment variables. So at a certain point, it starts complaining about that they cannot put more environment variables there. So we switched the strategies in Hop, and now we store them in parameter store, and they encrypted and integrated with Elastic Beanstalk, so you don't have to worry about it. And of course, another essential service is the identity and access management for doing all the security considerations about users, roles, and policies, so you can have a control over the resources your development environment access and the production environment access. And there are more services. I mean, these are not all the services that the Hop has available. You can, this is a diagram. This is actually in our documentation as well, if you want to look at the reference. And actually, there are also some security considerations that you might want to look at. And this would be the diagram with all the all available possible services that you can choose. Some of them are optional. As I said, for example, the RDS or the database service of AWS, it's entirely optional, Cognitive as well, so you can choose to obtain or out. And finally, to conclude or to give closure to this presentation, I just want to give some considerations about Hop or before you start using it. These are some answers to questions that we have gathered over the past couple of months. So the first of them is that you might have guessed, the application architecture heavily relies on Duct framework. We basically use it for most everything related to the application, from the application itself to also the supporting libraries. So changing it to a different alternative might be challenged or even not possible. Leiningen is the build tool that Hop uses, and at the moment there is no alternative. And this is basically the matter of fact that we have been using Leiningen for a long time. Back in the day when, if you remember, that we're still only boot and Leiningen was kind of the de facto build tool. And we have been using it ever since because mostly because it was since the beginning, and also because it is a bit tied as well with Duct, because we used to use Duct templates, which are also based on the Leiningen templating machinery. And as I said, the database is optional. You can use any database you want. We give the optional database that's Postgres, and in the case in AWS, the RDS service for Postgres, but you can choose to not use it and use something else. The AWS infrastructure is, as I said, very opinionated, and it demands experience with the cloud provider. So if you want to operate it and manage and dig a bit on that infrastructure, you probably need some experience with AWS as well. And last but not least, all deployment types rely on Docker containerization technology. So as I said, from the local environment to the CI/CD to the deployment infrastructure, it uses Docker for all those things. So for me, that was it. And thanks for your time. And now you can ask me questions.